In example 5, we're going to look at a function that is a piecewise function. At different altitudes in Earth's atmosphere, sound travels at different speeds. The speed of sound, s of x, in meters per second can be modeled by the following piecewise function. So it goes from 0 to 11.5, so on and so forth. And if you look at these functions, they're just lines. X is going to be the altitude in kilometers, and we're asked to find the average speed of sound over the interval from 0 to 80. This is a graph of what this piecewise function looks like. And as you can see, there's different areas. We could basically divide this into 5 different areas. We could go from 0 to 11.5, from 11.5 to 22, 22 to 32, so on and so forth. Okay. So that's actually what we're going to do in this example, similar to the absolute value problem that we did in class. The first one that I'm going to do is going to be an integral of negative 4x plus 341 going from 0 to 11.5. And if I go through and I integrate that, I will add 1 to the exponent, so that becomes an x squared. I will divide by 2, so negative 4 divided by 2 is 2. Plus 341x, and I will need to evaluate that from 0 to 11.5. Okay, after computing that, I end up getting 3,657. The next integral is going to be the integral of 295 dx going from 11.5 to 22. So that integration is pretty easy. And when I go through and do my fundamental theorem of calculus, I'm going to substitute 22 in for x and then subtract that product from when I substitute 11.5 in, and you should get 3,097 and 5/10. The third area is going to go from 22 to 32. Our function is 3/4 x plus 278.5. So here is 3/4 x. When I go through and integrate, I'm going to make that an x squared. Dividing by 2 is going to cause that 4 to become an 8. And then I'm just simply going to add an x to integrate the 278 and 5/10. I'm going to evaluate that from 22 to 32. And I will end up getting 2,987 and 5/10. The fourth integral is going from 32 to 50 of 3 over 2x plus 254 and 5/10. And so that would be, don't forget your dx here. When we integrate, we add 1 to the exponent, we divide by the exponent and get 3/4 x squared plus, okay, in this integral we just have to simply go ahead and multiply the x in, and then we're going to evaluate from 32 to 50. So when we do that, when you evaluate with 50, you should get 14,600 minus 8,912 for a total of 5,688. So those are the first 4. Okay, now I'm going to turn my page over to look at the 5th one. So in this case, we're integrating from 50 to 80. Again, we go ahead and add 1 to our exponent, so 1 becomes 2. We divide by 2, so this 2 becomes a 4, plus 404 and 5/10 x. We're evaluating from 50 to x, evaluated at 80. I'm sorry, from 50 to 80. Evaluated at 80, we get this number, minus, this is the number that comes when we evaluate at 50, for a difference of 9,210. So basically we can say that the integral from 0 to 80 of s of x dx is simply the summation of those 5 areas that we just calculated, which is 24,640. If we need to find the average speed, that is simply 1 over b minus a, so 1 over 80, times this integral that we just found. So we're simply taking our answer of 24,640 and dividing it by 80 to get our average speed of 308 meters per second.